part 2 begins on problem 715. Jovan is looking for an even better method. You'll remember at 712 part 1 we discovered angle side was a side was a shortcut. So he's looking at the set of two triangles below. Jovan thinks that EFG is congruent to HIJ, but he isn't sure if the triangles are drawn to scale. So it says read the math notes on your book, on your paper, sketch the two triangles at right, and then label the following information. 8, this is 68 degrees. F is 25 degrees. J and G are the same, and they're both 87. So this would be 87, and this would be 87. And it says IJ is 13, and that's the same as FG, which is 13. By the way, you'll notice the angles, you either need 1 or 3 letters to write an angle, and you need 2 letters to write a side. So that'll probably come up more as we go. So anyways, it says, convince Jovan that these triangles are congruent. Well, again, we know that triangle-angle sum theorem says that these triangles have to add up to 180 degrees, right? So essentially what we're saying is if I take 180 and subtract 87, and I subtract 68, these two angles, whatever's left must be this third angle. So it equals 25. So this angle is 25 degrees. And then I can do the same thing over here. I can say, all right, well, 180 minus 25 minus 87, whatever's left must be that third angle, and it is 68 degrees. So you can see here, hey, look, these angles are the same, these angles are the same, and these angles are the same. So we have all 3 angles the same, and we have one side that's the same, but it has to be a corresponding side. Again, the fact that they're 13 doesn't matter if they're not both across from the same angle. So this is across from the 68, and this is across from the 68. So they do correspond. Again, just to be clear, I want to say, if it had been these sides that were 13, now this is across from the 87 and this is across from the 68, those would not be congruent triangles. But that's not what we had. What we had was they were both across from the 68 degrees, so they were congruent. So convince Jovan these triangles are congruent. They are because of angle, side, which we learned at the end of 712 part 1. That is a shortcut. So how many pairs of corresponding angle measures need to be equal to be sure that the triangles are congruent? What is the minimum amount of information you need to determine that two triangles are congruent? Well, here's the thing. If I give you these two triangles and I tell you this is 50 degrees and this is 60 degrees, guess what this has to be? This has to be 70. And guess what this has to be? This has to be 70 because of triangle angle sum theorem. So did I really even need to know these third angles? I didn't. It turns out that 2 angles is enough. So really what we're learning here, and what's probably going to come up in the next question or two, is I don't need the third angle. I can actually say angle side is plenty because I'll know what the third angle is. Not only that, what if I have angle side angle? And these are different. This says that I have 2 angles and a side that's not between them are the same. Okay, that's what angle side says. This is angle side. And that is going to be enough to prove triangle congruence, because then I'll say, oh look, if these 2 angles are the same, well this third one has to be the same, right? Same thing over here. If it's angle side angle, let me go ahead and clear this off real quick. That's what angle side looks like. So angle side angle looks like this. We're saying, what if I have an angle, the side between the angles? So you can see here the S connects the A's. Well, the side connects the 2 known angles. And again, same idea. I can come along and say, well, if these 2 angles are the same, this third one has to be the same. And then we're right back to angle side, right? So it is really important that we understand the difference between angle side angle and angle side. Actually, I guess I screwed that all up. I should have. Now I can go. So it's almost like angle side is kind of like the grandpa, and these are well, I guess the dad and these are the kids, right? Because these are both true because this is true, and the fact that we only need two angles, and then we automatically know the third, right? If we have two angles of a triangle are the same, the third automatically has to be the same. So if I have two angles on the side not between them, well, I know the third side, then I have angle, 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 side. And if I have two angles and the side between them, well, then I have the third angle, which would be angle, 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 side. So again, the difference between angle, angle, side, where the side doesn't connect, the S doesn't connect the A's, the side doesn't connect the angles, and over here where the S does connect the A's and the side does connect the angles. They are different, and it's important that you recognize them as different. Alrighty, so we will go ahead and finish this thing off. So 712 part C, I believe. So problem 716 says, hold everything. Jovan's team member Kiem says, I see two different situations. This is what we just talked about, right? On problem 715, I was a little bit ahead of the game there. I see two different situations where we know two angles and one side. Look at some sketches I made from previous problems. Here you can see. So think, is this angle, side, angle, or is this angle, angle, side? Is this angle, side, angle, or is this angle, angle, side? These two, the two triangles on the left have a corresponding side that is between. The side connects the angles. This is angle, side, angle. I call that angle, side, angle, but in the two triangles on the right, the corresponding side is not between the angles. This side doesn't connect these angles. So this would be angle, angle, side, because the side doesn't connect. And these are our first two real shortcuts. We know that angle, 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 side is a shortcut that works, but we don't actually ever say angle, 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 side because it breaks into these two. So here's our first way of proving triangle congruence with a shortcut. Here's our second way of proving triangle congruence with a shortcut. Do both of these conditions ensure triangle congruence? They do. And what do you think? To demonstrate the two triangles, which condition is valid? Angle, side, angle, side. They're both valid. So there we go. We have these two as our first two shortcuts. Based on your conclusions from this lesson, decide if each pair of triangles below is congruent. If they are congruent, write a triangle congruent statement like this. Again, there's 6 ways to do that. Give the congruence condition such as angle, side, angle, or angle, angle, side. Right now, that's our 2 choices. And describe the sequence of rigid transformations that would map them. So again, if I look at this one, angle, 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 that's not enough, right? We know, we have said happy face. These ones are true. We said angle, side, angle, and angle, angle, side. We said those are good congruent shortcuts. And sad face, we said these ones are not true. Angle, angle, angle. Right? So this is not congruent because of angle, angle, angle. That's not enough to prove. If I go to B, here, if this is 10 and this is 150, and this is 10 and this is 150, this side is 58.5. It's first I'm going to check to make sure it's across from 150 degrees, which it is, so it's in a corresponding spot. Next, I'm going to say, so this is congruent. The question is it angle, side, angle, or angle, angle, side? Well, this side does not connect these angles. So this is going to be congruent because of angle, angle, side congruence. And I need to make a triangle congruent statement, so I'll just say CRD. I could have started at CDR or DRC. It doesn't matter, whatever I wanted. But now that I've started it, it's important that I finish it. C is the unknown angle, so I'm going to pick the one that's unknown, and it looks like Y is the unknown angle. And then R is 150 degrees, so I'm going to pick W because it's also 150 degrees. And then D is 10 degrees, and so is B. B is also 10 degrees. So here's one of 6 triangle congruent statements I could have made. Now, how are these things going to match up? Well, if I reflect this one and then translate it up, it should be fine. All right, on this one, 80, 35, 80, 65, we have the 150. Here's the problem on this one. This one I don't know for a fact yet. Just by looking, the 80 and the 80 match up, but this 35 and the 65 don't match up. So I actually have to do some math here and verify that this equals 65 degrees, which it does. And then I have to do some math here and verify that this equals 35 degrees, which it does. So now the question is angle side angle or angle angle side. Well, here I already knew it was angle angle side. I didn't need to do any math. But here I didn't know which it was. So now I have an option. I can either say, oh, I'm going to use this angle and this angle, so I'm going to call it angle side angle. Or I can say, oh, I'm going to use this angle and this side. So it's angle, angle, side. So I hope you understand the difference between here where we already knew it without calculating the third angle. And we just stopped and solved and said they were congruent. Whereas here I actually had to do math, and once I filled them in, now, you know, it's up to you what you want to use. Do you want to use the 80, the 150, and the 35? The 80, the 150, 35, whatever. But here's the trick. Let's see now. 150 is across from 65. Is 150 across from 65? It's not. They were tricking us. This is not congruent, right? Not congruent at all, because we have to check to make sure that they are corresponding sides. This is not a corresponding side, so it's a bit of a trick. Not congruent. I'm glad they put this in here because that's a big deal that we need to make sure that we're okay with. All right, next thing here we have 105 and a 55, 105 and a 20. So again, we have to do some math here. I know that this is 20 degrees. I do some math here. I know that this is 55 degrees. So I know the angles are all the same. I know the side's the same. Is the side corresponding? It is corresponding. So now we look at this, and here's the question. Just based on what we were given, we weren't given enough information, right? We had to do math here to prove these missing angles. So now the question would be, do you want to use the 105 and the 55? If you do, it's angle, angle, side. But over here, we couldn't use the 55 without doing some math. So what if we wanted to use the 105, 20 and 4.2, 105, 20, 4.2? That would still be angle, angle, side. But what if we wanted to use the 55, the 4.2, and the 20, the 55, the 4.2, and the 20? That would be angle, side, angle. So either one we want to use. So kind of tricky here. I will say triangle. Again, it doesn't matter. I'll say ACD is congruent. And this is a little bit tricky as well, because you see the A and the C, people just naturally assume the A must match up with the A, and that's not the case. A is 55 degrees. In this triangle, C is 55 degrees. Over here, C, in this triangle, C is 20 degrees, but over in this triangle, A is 20 degrees. And finally, D is 105 and the B is 105. So this would be one of our triangle congruent statements. Again, we could have written other ones, but this is the one that we chose to write right here. And it looks like if I reflected that across, actually it looks like I need to rotate this, right? I need to rotate this down so the 55 slides down here. So a rotation would go ahead and match these ones up. So that is 712 part 2.